CryptoviralTV, and I'm here with
안녕하세요. 있으시면.
and Charles Hoskinson.
Pleasure to be here, guys.
Obviously, you guys know who this is. Ada's running coffee from Ethiopia.
So we have an office in Addis Ababa, which is the capital of Ethiopia. We actually have a relationship with the Ministry of Science and Technology and some local universities. And we're doing two things in Ethiopia. One, we're training local developers to be able to develop applications to run on Cardano, and the best of which we'll hire as IoT employees. And second, once we're done with the training, we're going to begin doing supply chain management and modeling for coffee production in Ethiopia. So Ethiopia is one of the largest coffee growers in the world. They have about 1.5 million coffee farmers, and they have a very unique coffee supply chain. Where on one side, it's high tech. It was exchange created by a Stanford grad, fiber optic cables, supercomputers. And on the other side, you have 1.5 million farmers, most of which don't have electricity or stable internet, and they live on less than a hectare of land. And when they want to sell their beans, they actually text message washing stations and then carry the beans on their back and put them on a donkey and ride them out to the washing station. So our goal is to model that entire supply chain out, give digital identities to everybody, and then we can start thinking about financial products like microfinance and microinsurance and remittance transactions specifically for people within that chain, and to connect that to the Cardano ecosystem. So it's a long arc project. It'll take several years, but we have strong operations. And if it works there, it can work in any ag tech setting. So it can work on, banana supply chain, sugar cane supply chain. So we're really excited to see what we can do in the Caribbean and Central America and South America. We have operations actually in Barbados as well as Argentina. So we're planning for the emerging world. It's going to be a lot of fun.
I think Ada, every Korean thinks it's a good project, obviously, right? But it's the development is a bit slow. So like the other projects like EOS and like kind of stuff, they're really going forward, right? So Ada seems a bit of a conservative. So what do you think?
Well, Cardano is like an iceberg. So what people see publicly is the tip of the berg, and then there's a lot of things that we're doing subtly underneath. So the first major challenge was the heart of the system we had designed correctly, the proof of stake protocol. And this is completely new engineering. Whereas if you look at projects like EOS, Dan's been working on DPoS for 4.5 years. And he created graphene and these things. So usually what he does with his projects is he takes what he's done and just builds on top of that, So the heart of EOS is quite old. And it's actually not really based on really advanced technology. What they did is they took the Byzantine Agreement protocol and put a voting system with it to decide who's in the quorum. But it's just 21 nodes running in a Byzantine Agreement. That's like Hyperledger Fabric with a voting system. There's nothing special there. Whereas Ouroboros was built from the ground up to try to solve all of the problems of proof of stake. But the problem with that is that you actually had to build all this theory out to actually understand what are the problems. So we started with GKL15 and the bottom of the iceberg, and we said, what is a blockchain? Then we asked, does proof of work create a secure blockchain? And we proved that. Then we proved proof of stake to be of equivalent security, but it didn't have realistic assumptions about it.
Of course.
Okay. So then what we had to do was gradually relax proof of stake and say, can we move from a synchronous model to semi-synchronous and do all of these things? And these papers are not interesting to the investor or to the engineer. They're interesting to the academic. So we spent now $2.5 million. We've written half a dozen papers from more than 10 universities participating, and we've built out the entire theory of proof of stake. We're now at a point where we actually have a protocol that we feel very comfortable with. It can do delegation, we have a great incentive scheme for it, and it has all the security properties that you expect with proof of work. So we show how to resolve long-range attacks and grinding attacks and number of stake and so forth, but it was a huge investment. So the other side of it is that we've chosen to develop a methodology which by its very design is a little slower. So we use what's called formal methods. So we say we're going to write a specification and then extract from the specification code and then show that that code is correct. Now the advantage of this is you don't have the DAO hack or the parity hack, and the system works quite well once it's deployed. The disadvantage is your set of developers who can do this is much smaller.
Yes.
So you don't when you're going from like JavaScript, many, and then Java, and then C#, and then you go to smaller languages like Haskell, and then you go to formal methods. It's much fewer people. So it took us about 2 years for us to find a critical mass of good developers to work on that code base and be able to do it. But now IHK actually is very well staffed. We have probably the largest group of Haskell developers in the world at our company, and we're sufficiently well staffed to move quickly. So we're starting to see this with the releases. Cardano 1.1 took about 6 months to get to. 1.2 took about 4 months to come out. 1.3 is coming out next month, and 1.4 will come out in October. So we're seeing very rapid progress with being be able to get things out faster. And entering 2019, I think we'll be able to release just as fast as Lisp does or EOS does or these other projects do, but we'll keep our principles and our core technology, and a lot of our base protocols will be based on peer-reviewed research. So you pay a lot more money and time up front. It's a lot harder to get it started. In this case, it was several years, but we paid that fee, and you get a lot of benefit on the back end that once it's built and deployed, you know it works and it's secure and it's performant.
I guess it's very different in the sense that most other platforms don't have to develop full business architecture, and they're based off of real products and architectures that kind of already existed as a technology.
But those architectures don't scale.
Exactly.
I mean, if you want to go from 10,000 users to 1 million users or 1 billion users, you can cheat and centralize the system. That's what EOS has done. And yes, it'll work, but you're basically handing control over to a small group of super users that you really can't get rid of. Because if the person has millions of dollars of infrastructure, yes, you could technically vote that person out, but then you lose the millions of dollars of infrastructure that person has. So their sins must be very egregious for them to be removed. Whereas if you want a truly decentralized system, you have to use fundamentally different technology. And proof of work doesn't work because it's centralized around less than 1090.
Exactly.
Right? So you need to do some things differently. The other thing is you have to figure out how do we add new functionality to the system. If you look at the internet, we have TCP/IP. And it's been around since the 1970s, and the guys who created that had no idea about Wi-Fi or Google or any of these things. Yet despite the fact that it was built so long ago, Google's still using that technology, right? Why? Because it was built in a layered way. And we designed Cardano to be the same type of architecture where you can add layer after layer after layer, including layers that we never even imagined. The problem is that to do that, you have to think very carefully about how do you extend it, how do you preserve the security guarantees, how do you move value between the layers when you get a sidechain transaction. And all of these things do take a lot of time to carefully think about, because our intention is for the protocol to be useful for decades as opposed to years.
It's very interesting because Haskell code itself, even among other developers, I guess comparatively to Solidity, there's a very few and limited amount of developers.
Yeah, it's important to point out you do not have to use Haskell to write smart contracts for Cardano. In fact, this is one of the most common misconceptions we've seen in the space where people say, oh, well, nobody's going to write software for your system because they have to use Haskell. It's like, no, we actually have 3 different computational models for Cardano. One of them is a legacy model, so it's Ethereum virtual machine. So anything that works on Ethereum works on our system. So you can use Viper and Solidity and whatever Vitalik comes up with, I'll be able to use that. Second, we have a system called Yella, which is launching at the end of this month in testnet. And Yella's been built based on LOVM, which is something Apple created. So Steve Jobs himself picked this project, and he was very keen to get it done. But anyway, Yella is our interoperability layer, so you're going to be able to write smart contracts in JavaScript and Java and C, C++, or normal programming languages that developers really care about. And then we have something called Plutus, which is based on Haskell. In fact, the guy who created Haskell is working on Plutus. So we have a very strong team there, and that's for high assurance contracts, for like things that involve billions of dollars, or utilities, or aerospace software, where if that fails, people die, or lots of money's lost. But you can use any one of these models, whether you're going to be focusing on legacy interoperability, developer accessibility with the tools that they come to know and love, or high assurance. You have all 3 options because of our work.
In terms of technology base, from Reddit postings and keyboard warriors online, and a lot of investors. I mean, I was a pretty early investor in terms of Cardano, but a lot of it has been that the speculation that the technology itself is so ahead of its time to a standpoint compared to the other technologies that are out there in, I guess, in the crypto sphere. And my question is the adaptability. What issues have you guys seen with scaling and user adaptability in terms of development of dApps? And what would you say is the biggest issue behind as to why a protocol or a platform like Ethereum has so many developers, but platforms otherwise don't?
Well, when you say so many developers, the first thing you have to do is put it within the scale. So if you say so many developers, there's JavaScript developers, and Android and iOS app developers, and C# and Java developers, and Solidity developers. So it's like, if you compare these things relative to the broader development field, Solidity is a very bespoke boutique language, and being a smart contract developer is very bespoke. The other thing is, when people actually build things for Ethereum, the very first thing that they do is they learn how to get out of Ethereum. And what I mean by that is they build this protocol and or whatever their DApp happens to be, but then they introduce trusted servers or some federation or some layer 2 protocol to actually run it because it's prohibitively expensive and slow to run it on chain.
Scale.
Right, so it doesn't scale at the moment. So then Vitalik says, well, okay, when Casper and Plasma comes out, it'll be magical. But we've heard this before. We've heard it with Lightning and sidechains with Bitcoin. It's like when these new things come out, everything will be fixed. But the reality is it's much harder. First, it's not clear how the server, the client, and the blockchain need to work together. And what I mean by that is if you look at an application, not everything is going to run on blockchain. This whole idea of we're going to throw away Rackspace and Amazon and all these things and then somehow it's going to replace these servers, that never makes sense from a cost perspective because you're taking extremely optimized, incredibly well-constructed, very curated, commoditized hardware and replacing it with decentralized, replicated consumer hardware with unoptimized protocols. If you're doing an apples-to-apples comparison, Amazon will always be faster, Rackspace will always be faster, Azure will always be faster. So it's less of a question of how do we get rid of those guys, it's more of a question of how do we augment the trust model so that when we use those guys, we get the benefits of their performance and their efficiency and their low-cost operation, but we don't necessarily have to trust them for everything. So I'll give you a great example of that. So let's say you're running a poker application. There's all kinds of things with that application that would make lots of sense to run on a centralized server. But what you care most about is the house can't cheat. So the random numbers are generated properly, the cards are shuffled properly, these types of things. So why don't you take those aspects and run those in a more decentralized model, but then everything else like player matching and GUI and other things will either run client-side or run on the server because that can be optimized. And then when you put all these things together, it's as if it ran all on Ethereum, but it runs at 100 times lower cost, right? So this interoperation between off-chain, on-chain, blockchain, server, client is what matters more than can we make the blockchain faster. That'll come naturally. There's lots of ideas and protocols and all kinds of ways you can cheat to get more speed. Also, in a lot of types of computation, especially non-interactive ones, we have very powerful tools that are being developed in academia. Like at Microsoft Research, the Pinocchio project, the Geppetto project, where you can do this huge computation off-chain, and then when you hand it to somebody, you give them a proof of correctness. They don't have to redo the computation, they just check the proof, which is constant size, regardless of the amount of size of the thing. So for example, like folding a protein. Under ordinary operations, if I give you a folded protein, the only way you can verify that the protein has been folded correctly is to fold it yourself, which defeats the purpose of outsourcing the protein, right? But what if I give you a proof of correctness? I give you the protein and the proof. You look at it and you say, well, the proof checks, so I know the protein's been folded correctly. And you can validate the proof in constant time, regardless of how complicated that protein happens to be. So for a whole class of computation, you can do all of that off-chain once these proofs become commonplace, called verified computation. There's another thing, interactive computation. So we have a whole lab in Japan at Tokyo Institute of Tech, and they study multi-party computation. And there's other projects, one at MIT called Enigma. And these projects are talking about how do we take smart contracts and decentralized exchange and all of these things that you'd like to do on-chain and bring them off-chain and get all the benefits of the speed and the latency and the fact that you don't have to store all this information forever, but then still have the same trust model as if the computations happened on-chain. So these layer 2 protocols, whether it be MPC or state channels or payment channels or cryptographic techniques like verified computation, in my view, are more meaningful to the scalability question than can we just make the base chain faster or shard it with side chains or something like that. That's going to happen naturally. We have ideas on how to do that. We'll get much better performance, but we need the other thing to be able to go to a system with millions to billions of users.
We asked you a lot of technical questions. I'm sure the viewers will have a hard time Googling and a lot of time searching. In terms of where you see the blockchain industry moving within the short-term periods, a lot of what you were talking about are permanent solutions. And what we've been doing in the blockchain industry is, or this is just my personal opinion, is putting a band-aid on a bigger problem that needs to be solved. What you're talking about is an actual solution to the full-blown problem. My question is, that's not very incompatible within the near future of a year or two from now.
Right.
What do you see as the most interesting project nowadays into solving in the short-term process?
Well, I mean, you have to have this balance between principles and pragmatism.
Yes.
So, if you want to verify that your operating system is secure, you can do that. It's been done once before. It was through a project called SEL4. It took them hundreds of millions of dollars in 10 years. It was a long effort, right, to get a verified microkernel. So that's probably two principles. But then on the other hand, pragmatism can lead you to build things like the DAO. You build things like the parity smart contract. And while you get to market very quickly, what you've brought to market, you've fundamentally flawed in a very damaging way. And ultimately, you hurt consumers. So you have to find some balance between these two different roads. And there are some projects that actually I think have done a very good job with the balance, where either they were too far on one side or too far on the other side, and they found a way to meet in the middle. Ethereum in particular recently has been making some great moves. They put some great money into Stanford and Dan Bonet and David Mazeres, and Casper and Plasma are finally actually starting to look like real things as opposed to academic projects or Vitalik's brainchild. And I think projects like that are really demonstrating that you can find your way after you've been criticized enough and beaten up enough. Cardano, I think our flaw has been that we've been a bit too much on the principle side and not so much on the pragmatic side. And so we've made some compromises there to try to speed things up. For example, we're building another version of Cardano in Rust as opposed to Haskell. And we'll have that out probably September to October, and then you can use it to build mobile clients. In fact, we've already tested it on iOS and Android. You can also use it to build browser-based wallets and so forth. So I think that'll help us get things to market faster. We've also started trying to diversify some of our projects and make our projects perhaps less ambitious, so we can bring certain things about Cardano faster to market, even though they're not necessarily perfect. So we've learned that we needed to be a bit more pragmatic over principle. Other projects I think are a bit too pragmatic. For example, IOTA in particular. This is where they started with something really novel and interesting, IOTA, but that paper really did require, Tangle, that paper really did require a lot more evolution and a lot more thought, but they just brought it to market as quickly as they could, and instead of having the mentality of, well, if you do that, you're going to make lots of mistakes and a lot of problems, and being humble, and when people find them, admitting them and moving on, they've adopted a strange mentality of, we don't have any flaws or mistakes, and when people audit us, the auditors are biased or something. So I think any project that does these types of things thinks that they've solved everything. You're doing it wrong. I make mistakes all the time, everybody does, even the best of us do. You need to be humble, and you need to say, yes, I'm not God, I need to move on.
That's really the point of this industry, right? I mean, they say that we're at the complete infancy stages of the 1%, and if I guess the blockchain itself, like the technology base behind it, would be at 100, we're at the 1-2% very infancy stages, and we're just learning and figuring out what it really is.
Yeah, but things move very quickly. Like in 1990 to 2000, you look at internet adoption, we didn't have the web browser, the notion of the ISP, any of these things in 1990. In fact, it was illegal to do e-commerce in 1990 because of the NSFAUP until 1992. So, that's one side of it. And by the year 2000, we had Google and Amazon and web browsers, and everybody had email addresses and so forth. And then you go from 2000 to 2010. We had these massive internet giants like Google and so forth. So things happen very quickly.
Especially in blockchain.
And blockchain were probably faster than the adoption of the internet. So in 5 years, this could be very mainstream.
카르다노의 궁극적인 목표는 전기와 기타 다른 노력들 없이 작업 증명 방식이 가진 안정성과 기능적인 특징을 완벽하게 제공하는 것으로 보입니다. 우르보로스 알고리즘의 현실화에 대해 궁금해하는 사람들이 많은데요. 언제쯤 완성될까요?
Yeah, so the algorithm will never completely be done because it's a completely new class of algorithms. So just like Byzantine Agreement, the first protocols in that area came out in the 1980s. We're still working on them 30 years later, and they of course come up with new flavors all the time. But the question should be, when do we feel that Ouroboros will have the same security, performance, and efficiency profiles that proof of work has? Because at that point, you get all the benefit of something as if it was proof of work, but you don't have all the costs.
Exactly.
And actually, Ouroboros Genesis for us was the moment. So we started with Ouroboros, which was mostly a theory-based protocol. It wasn't a practical one. So it was very synchronized and it required all these trade-offs that were not desirable for a real system. But then it proved that proof of stake could be secure. Then it was a race to figure out how do we actually relax these assumptions and make the protocol practical. So the first major step in that was Ouroboros Kraus. We made random number generation 1,000 times faster. We made it a semi-synchronous system. And at that point, if you implemented Kraus, you actually have a really good system, and you could run a cryptocurrency. But what Genesis does with Kraus, the next version of the protocol which we just came out with, is Genesis gives us the same property that Bitcoin has. And so what is that? It's the longest chain rule. So let's say that he's completely new to the Bitcoin network. He knows nothing about Bitcoin. And he gets a chain from you, a chain for him, a chain for him. So how does he know which one's the right one? Okay, with proof of stake, you would know from the checkpoint. So you'd have to trust somebody to have watched the system, and then you have that checkpoint, you check all the chains, and you say, this one matches my checkpoint, that's the right one. Or you use a heuristic argument. With proof of work, you don't trust anything. You do a calculation. His chain, his chain, his chain. Which one's the heaviest? That's the chain I'm going to go with, that longest chain rule. So with Ouroboros Genesis, we were actually able to replicate that property, where you don't actually need a checkpoint or to trust people. You could just look at all these different chains, and whichever one actually turns out to have been the heaviest chain, that's the one that wins, because you don't have to be mining it. That's a revolution for proof of stake. It's never been done in any proof of stake protocol, and it required a very, very rigorous paper. Proves the thing in global universal composability. We did a lot of heavy lifting, and we brought a great international team of people together to be able to prove it, from Switzerland to Greece to the UK to New York. And so forth. And so now we're at that point, it's now practical considerations, like how do we do delegation, how do we do the incentives. We have a delegation paper coming out, an incentives paper coming out. So I'd say version 1 is done. And now it's just a matter of building it, and the implementation can happen in very short order. So Q1 of 2019, we should see the first flavor of that.
Q1 of 2019.
But there's going to be more to do. So we have another version of Ouroboros we're working on for sharding, called Ouroboros Hydra. And we have a whole team of people thinking about that. We're looking at all these sharding protocols like OmniLedger and Thunderella and other ideas for sharding like Plasma, and we're creating kind of a theory of how does one shard proof of stake in general, and that's going to be the very next update that we do beyond Genesis. And at that point we can go from a single shard, single ledger solution to a multi-ledger, multi-shard system, and that will allow us to go to much higher performance than the existing system.
I'm very excited for Q1 of 2019.
Yeah, it's a lot of work. We've been working really hard.
To ask you some non-technical questions, so I'm sure you've been in Korea pretty often. How do you view the improvements and the growing of the size of the market in the Korean blockchain industry within the last 6 months to a year?
Yeah, it's really amazing. Korea, it came out of nowhere. China and Japan were kind of the big markets. And Korea was little as a market. No one really cared about it. And then now it's like the biggest market.
Yeah.
Right? You guys have really achieved a lot in a very short period of time. I also see a lot of interest from Samsung and Hyundai and all these other large companies who are saying, hey, let's do a lot of enterprise blockchain. Funding is going up and up and up, and regulation is getting better. So I think Korea is probably going to be one of the largest and most prominent global markets for the blockchain space, at least in Asia, and perhaps in the entire world. So it's not a market you can ignore. And actually, Korean entrepreneurs are very good, very competitive, and they're able to adapt quickly. Like they can take the best of anything within 6 months and run with it and create something better. So we really look forward to being in this marketplace, and we might even set up actually a research lab. We've been in some discussions about that, or some other place. So we've been looking around, but I think this is going to be one of our largest markets.
I'm very, very interested to hear about that. So in Korea, there have obviously been a lot of industry giants that are coming into the game, a lot of corporations, a lot of startups, and we've seen the industry grow. And I've been here as a local for the last 6 months. It's been insane. But the amount of conferences and the amount of TV shows and things like that and media coverage has gotten a lot better. So Asia Economic TV and a few other groups are putting together a global blockchain TV program. What do you think about that? Like it's I guess to appeal to the masses?
Yeah, well, that's exciting. I mean, blockchain covers everything. It can go from financial inclusion to supply chain management to voting systems, privacy, identity management, reputation, credit systems, insurance systems. So there's an enormous amount of content. And yeah, it'd be fun to talk about it. And if anything, just the philosophy of control. At the end of the day, we already have gotten all these systems from our fathers and our grandfathers and our mothers and our grandmothers, and we didn't really think so much about how they're constructed. Like, why do you vote the way you vote? Why does your money work the way it works? Well, you didn't decide that. Someone else did, who's probably dead or very old. And so now we have all these new tools and technology, and we're having a global conversation about changing these things.
We're kind of like going back to the basic foundation of the basic questions.
Exactly. And so then there's questions of who should be in control and how much control should they have and how much should you trust them. So that's not a conversation that should only just be held by some elite academics or government officials or engineers. That's a very global conversation that should be held by everyday people. Like, how would you like to get your loans in the future? How would you like to vote in the future? So it'd be nice to bring these concepts to the masses and let people know for the first time in their lives they actually have a say in this matter, not just a small elite.
We hope to see you in Korea very often. I'm very excited. I've been excited about the Predator project since early last year, but yeah, great to hear that you guys have so much in store. Very excited. And if we could say bye to this camera on the count of three, I'll say 감사합니다.
Okay.
You can get it?
감사합니다.
Okay, bye.
And then one more thing. 에이다 가자. Yeah.
에이다 가자.
에이다 가자. Do you know?
가자!
Yeah. Could you say to?
Hi.
Alright, 1, 2, 3. 에이다 가자.
가자! Thank you guys.
감사합니다.
Thank you so much.
Thank you so much.
No, of course. Thank
It
you.
was a lot of fun. Thank you so much.
Thank you
Hope
so
you guys
much.
enjoyed it.
No, of course.
Yeah.
I love
Sorry you had to
hearing
wait so long.